Good evening. We are welcome to today's class. That is the 8th class in chemistry 205, inorganic chemistry. And as I told you in the previous class, today we are going to have a general survey or review of what we have gone through so far in this class. We looked at the P block elements. The P block elements comprises of group 4, group 5, group 6, group 7. Or in some books, you'll find it as group 14, 15, 16, and 17. They are so-called P block elements because they have electrons that are entering into the P orbitals. There are general things that you need to understand about these 4 or 5 groups. One is that the first group, which is the carbon group, like we said in our previous class, it has an outer configuration of NS2 and NP1, NS2 and NP1. And if you go through all the groups, the next one, which is 5, is NS2, NP2. The next is NS2, NP3, NS2, NP4, NP5, NP6, and NP7. Generally, in the group, there are trends that you need to understand and keep in record. Take note, in all the groups, as you go down the group, the size of the atoms increases. All the groups. Secondly, as you go down the group, electropositivity increases. Electropositivity increases. As you go down the group, metallic character increases. Metallic character increases. As you go down the group also, reactivity increases. Reactivity increases. These 4 or 5 properties that I mentioned are common for all the group from group 4 to group 7, or otherwise 14 to group 17. Now, across the period, as you move across the periods, the size of the atom decreases. As you move across the period, the size of the atom decreases. As you move across the period, electronegativity also decreases. As you move across, electronegativity actually increases as you move across the period. Electronegativity increases. So as you move across the period also, the effective nuclear charge also increases. So there are some of these properties that are common for almost all the elements. Now, as you also move across the period, you discover that the tendency of actually accepting electrons or sharing of electrons to form bond also increases across the period. Now, these are basic things that we need to know. So let's have a brush look at the whole group. The first group, which is the carbon group, that is group 14. We say this group comprises of carbon, silicon, germanium, tin, and lead. And we said in this very particular group, we talked about their occurrence, we talked about their extraction, and we talked about some of the other properties of the group. We talked about their uses. We also talk about some concept like allotropy. And we said allotropy is when an element exists in more than one different forms, but they have the same chemical properties. Take note of that again. Allotropy is the existence of an element in more than one different forms with the same chemical properties. We also talked about catenation, that this very particular group has the ability to catenate. And the term catenation, we also try to define it, that the ability of an element to form long chain of long chain with itself, the ability to form long chain with itself. An example is carbon. Carbon can be able to form a long chain that exists among the carbon atoms. And we mention some peculiar allotropes of carbon. We say carbon exists as carbon graphite and as carbon diamond. Carbon graphite is soft and is jewelry in nature, while the diamond is actually stronger. It conducts electricity, it is hard, it has the localized orbitals, and so on and so forth. Now, when we get to, we also try to look at the carbides, the halides, the fluorides, the hydrides, and the oxides of this very particular group. So we picked each of those one after the other and try to examine them and see how actually they are. Now we move to the next group in our study. We try to look at the next group, that is group 5. Group 5. Group 5. And we say group 5 comprises of nitrogen, phosphorus, arsenic, antimony, and bismuth. Nitrogen, phosphorus, arsenic, antimony, and bismuth. And as mentioned earlier, the first group, which is nitrogen, it is a non-metal. Arsenic and phosphorus are metalloids. Bismuth is actually metallic. Metalloid means that they can exhibit both metallic and non-metallic character. They can exhibit both metallic and non-metallic character. And note, one of the common properties again of all the groups is that every first member of the group tends to behave quite different from other members of the group. Every first member of the group tends to behave quite different from other members of the group. Like the earlier group, we mentioned the carbon group. Carbon exhibits some anomalous behavior compared to the other member of the group. Here in group 5, nitrogen exhibit anomalous behavior. The reason is that they have smaller size. They have smaller size and they have higher electronegativity value. And because of that, the influence or the force of the nucleus on the outer electrons also differ compared with the other members of the group. And as a result, they exhibit a lot of differences with other members of the group. We said in this group 5, nitrogen is exceptional. Why? Because it is a major component of the atmosphere. It is a major component of the atmosphere. And we also try to point out that nitrogen sometimes is found actually in form of chloropatites, fluoropatites, and so on and so forth. We look at their extraction, how they are actually obtained in nature. We also look at their uses of this very particular compound. But in this group also, there are particular interests which we showed. One in nitrogen. Nitrogen being used as fertilizers, particularly in the nitrate forms. It is used in the manufacture of ammonium nitrate and nitroglycerin, or sometimes nitrogen is used to form some armories or chemical weapons, like you have the TNT, trinitrotoluene, TNT, trinitrotoluene, which is one of the components that is used in the manufacture of bomb. Or hydrazine. Hydrazines are also some components that are used for the manufacture of bombs. And we also try to look at the nitrogen cycle. We looked at the nitrogen cycle, and we also looked at the allotropes of phosphorus. That phosphorus has the ability to exist in more than 3 forms. Like you have the white phosphorus, the red phosphorus, and the black phosphorus. We also try to look at the nitrogen cycle. Nitrogen cycle. That is how nitrogen is maintained in the atmosphere, how nitrogen is constant in the atmosphere. And we look at one, nitrogen fixation by bacteria, and how nitrogen fixation by bacteria. We also try to look at how elements actually utilize the nitrogen by plants, and there is that form of the ammonium source or the nitro source, or nitrogen which is being converted by plants for their own use or other things that actually want to eat. We also look at the bacterial method. There are certain bacteria that also convert atmospheric nitrogen into ammonium salts. And we say the rhizobium. Rhizobium, which lives in the root nodules of leguminous plants, has the ability, like beans, has the ability to actually fix the nitrogen that is taken. They can fix it. So if sometimes what agriculturalists is, if there is a soil that is deficient of nitrogen, what you do is that you plant leguminous plants there, like beans. So after some years of planting, more of the nitrogen that has actually been depleted from the soil are fixed back into the soil. And after that, that soil becomes very, very productive again for the growth of certain crops that ordinarily before could not be able to grow on such kind of soil conveniently. We looked at some compounds of phosphorus as well, and we say the phosphate fertilizers, whose main component is the phosphorus. They are also used actually to get fertilizers so that we apply them to the soil, and that improves the soil texture and the soil content, thereby helping in the growth of plants. We talk about also the anomalous behavior of nitrogen as the first member of the group, that it has smaller size, it has higher electronegativity value, it has the tendency to form stable multiple bonds, and is because of the non-availability of the d orbitals, it cannot be able to expand its octet. And that is also another characteristic that is common to all first members of the group because of their smaller size and because of the non-availability of d orbitals. They cannot be able to expand their octet. So their oxidation number would not be able to extend to around 5, 7 oxidation number because of the absence of the the of the d orbitals. Now the next group we also we looked at was group 16, that is the chalcogens. The chalcogens, which comprises of oxygen, sulfur, selenium, tellurium, and polonium. We said the first member, which is oxygen, is a non-metal. And they are called chalcogens because they are all forming compounds. They are called chalcogens, meaning all forming compounds. Most of the elements are used in the formation of ores, or most ores actually exist as oxides or as fluorides. There are few of the cellurides that have been seen, but most ores are actually oxides or fluoride ores. And as we said in our previous class, that the first members are actually non-metals, except for polonium, which is polonium is a radioactive metal. It's a radioactive element which is short-lived. It does not actually survive or stay or live for a very long time. Why? Because of its short half-life. It cannot stand for long. We talked about their outer electronic configuration as Ns2 and Np4. The Ns2 and Np4 actually signifies that they are mostly found by forming compounds by gaining 2 electrons, thereby forming -2 ion. They form -2 ion. Or sometimes they share electrons in forming covalent bonds. So the electronegativity value of oxygen in the group is the highest. And it is actually second to fluorine in the periodic table. And its oxidation state is -2. Its oxidation state is -2. Now, we saw also these elements, particularly oxygen. Oxygen is of very high importance. Oxygen, as we are aware, that's what we use in our respiration. We are able to survive today or live today because of the presence of oxygen. If oxygen is withdrawn from the air for a short while, life, particularly for animals, will not be palatable. They cannot be able to survive it a long time because of the lack of oxygen. We also see how you can prepare oxygen in the laboratory using potassium chloride at 150 degrees centigrade in the presence of manganese oxide as a catalyst. So oxygen will actually be released. And we also look at sulfur as one of the important members of the group. And we said sulfur is always found in combined states, but mostly sulfur deposits are actually found on the ground. Sulfur deposits are actually found on the ground. Now, because they are found at the depth of the earth crust, how do you actually try to mine sulfur? And I said that there is one major process that is used, that is the French process. The French process is the process that is used in order to mine sulfur. Now, in French process, 3 concentric pipes are actually bored to the sulfur depth. 3 concentric pipes are bored to the sulfur depth. Now, hot water or hot steam is passed through the outer uh, pipe. Now, hot air is passed through the central part. That is the central pipe. The hot steam that goes through the outer pipe, after reaching the sulfur deposit, melts the sulfur to become a molten sulfur. What the compressed air does that passes through the smaller pipe is that it now forces the molten sulfur to come out through the surface. Now there is a collection point that is prepared. So when the hot air inside pushes the sulfur out, it is collected out through the central pipe, the one at the middle. It is collected out. And sulfur mined through such a process is always the purest form of sulfur, and it's very, very important and very, very useful. The next group we tried to look at was group group 7. That is the halogens. The halogens comprises of fluorine, chlorine, bromine, iodine, and astatine. I take that again, that the halogens consist of fluorine, chlorine, bromine, iodine, and astatine. And we say their chemistry is very interesting and have varied application in daily human life. They do not occur free in nature due to their high reactivity. They combine with most of the elements. They combine with most of the elements. So they are mostly not found actually free in nature. They are always found in combined state. Now, we also try to look at their extraction, like the extraction of maybe chlorine, which is, or fluorine, which is obtained from the electrolysis of potassium fluoride. Fluorine, which is obtained from the electrolysis of potassium fluoride by dissolving it in anhydrous hydrogen fluoride. Or chlorine, which is a byproduct of the electrolysis of brine. We know the electrolysis of brine. Electrolysis of brine is actually the production of sodium hydroxide. So of sodium. So at the end of the day, sodium is obtained and chlorine is also obtained. So such chlorine can be separated and collected differently, and that can also serve as one of the methods in which chlorine is actually obtained. The main use of most of these compounds is in halogenation of organic and inorganic compounds. They are used in halogenation of organic and inorganic compounds. Iodine, for instance, if it is dissolved in alcohol, it serves as an antiseptic. When iodine is dissolved in alcohol, it serves as an antiseptic. And when iodine is present in thyroid hormone, that is a deficiency of iodine, which is actually called goiter. Deficiency of iodine is called goiter. And that's why sometimes some of the toothpaste we actually use, you find out that fluoride are added to it or iodine is added. The essence is that they want to prevent the development of goiter by human being. And liquid fluorine is actually used as an oxidant in rocket fuels. In the old, liquid fluorine is used as an oxidant in rocket fuels. Teflon, on the other hand, which we are mostly familiar with, and is also a household product, is used for coating on kitchenwares or kitchen utensils in order to prevent sticking of some oily materials on the kitchenwares. Things like fluorochlorocarbons, CFCs, they are used in refrigerators as refrigerants to cool. So you use chlorofluorocarbon. So you discover that so many, the halogens have so many uses, like chlorine. Chlorine most of the times actually is used in the manufacture of polyvinyl chloride. Used in the manufacture of polyvinyl chloride because of its non-inflammability. Because of its non-inflammability, is used in the manufacture of polyvinyl chloride. And also, chlorine can also be used in a chemical warfare, particularly in the First World War. Chlorine was used actually in chemical warfare. Some of them also like DDT, dichloro, diphenol, trichloroethene are used as insecticides, even though it has been banned for sale in the market. But for those of us that are involved in soil research, we still see the use of DDT by farmers actually in the soil that we analyze. So generally, like I said before, that we are going to have this class by having a general review of all the groups that we have looked at. And I'll also give you time if there are some gray areas that you need some clarification, which you can ask me, and we'll try to see how we can understand each other. I've told you before that there are properties which you must take note of. That one, across the period, there is increase in electronegativity. Across the period, there is actually decrease in size. Across the period, there is also increase in gaining of electrons or sharing of electrons across the period. And we said also across the period, there's increase in the effective nuclear charge on the atoms. Now down the group, we say the size of atoms increases down the group, thereby decreasing the electronegativity and increasing the electropositivity as you go down the group. Also down the group, metallic character also increases as you go down the group. So most of these properties are common, and if we are asked, we should be able to have some of those general behaviors across the periods and down the group. I also told us earlier that for each of the group, the first member is always 16 with different behaviors and different properties and characters combined to other members of the group. And the term used for this is anomalous behavior. Each of the member, like carbon, nitrogen, fluorine, oxygen, and the rest of them, chlorine, they have anomalous behavior. Their behavior differ remarkably from other members of the group. Fatima, I can't see you again. I don't know whether you have gone, but I wish and I thought that we can interact. And if there are questions, you have been a very faithful and consistent attendee in the class. So if there is any question, which I expect you, I actually said that people should send to my mail so that we'll be able to discuss them today. But nobody sent any question to my mail. I hope we will be able to do that. We can have correspondence. You can send to my mail. If there's anything, I can still say right back to you and send you some replies. So once more, I want to say I'm very grateful, and I want to thank you for finding time to attend this very particular class that we have today. And this is our last class. I wish you the best in your examination. Thank you very much.